you are going to learn about uniform circular motion and non-uniform circular motion. First, uniform circular motion. During circular motion, direction and velocity changes. That's common one. When a circular motion is said to be uniform, when an object undergoes a circular path, its speed remains constant. Then that circular motion is called uniform circular motion. And here the object is refers to as point object. Point object means the object is considered as a point. So if you take example here, is it an object and it is considered as a point, so it is called as point object. It is moving in a circular path and its velocity is indicated as a red arrow mark and its direction is in this way. It is denoted in green arrow mark. And if you see the velocity, the distance between each corresponding velocities are same and the time taken by the object to travel this is also same. So this all indicates the path the object undergoes uniform motion. Velocity changes but speed remains same. In other words, the magnitude of velocity vector remains constant. So here magnitude of velocity vector is called speed. Take down, magnitude of velocity vector is called speed. So it remains constant and direction only changes. This is for uniform circular motion. Next is centripetal acceleration. We already know that acceleration is rate of change of velocity. And what do you mean by centripetal acceleration? This centripetal acceleration comes only for uniform circular motion, not for non-uniform circular motion. So acceleration in uniform circular motion is called centripetal acceleration. See the velocity, as you see in uniform circular motion, velocity have equal length and equal distance and they point towards the center of the circle. See, all the velocity, it's towards the center of the circle. So the acceleration pointing towards the center of the circle in uniform motion, that's why it is called centripetal acceleration. So can you understand this? Velocity pointing towards center of the circle, so acceleration also pointing towards the center of the circle. So the expression for centripetal acceleration using geometrical relation between position and velocity vector. So consider a point which is at a center and undergoes a circular path and its initial position is r1 and moves to the position r2 with a velocity v1 to v2. And this diagram is after a body moving, after that object is moving. So delta r is change in position vector, delta v is change in velocity. If you take before the particle moving, r1 is equal to r2, it is denoted by r, and v1 is equal to v2 and it is denoted by v. If the particle moves, it moves from r1 to r2 and delta r will be r2 minus r1 and the velocity changes from v2 minus v1. And now the magnitude of displacement and velocity is given by delta r by r, which is equal to minus delta v by v. Here minus sign indicates, we already know that uniform circular motion velocity is pointing towards the center of the point, that is inward. So that's why we are putting minus here, and which is equal to the angle theta. The angle between the position vectors is theta, which is given here. And now delta v is equal to minus v delta r by r. Here A denotes the acceleration. In this uniform circular motion, this A is called centripetal acceleration. So common acceleration formula is rate of change of velocity delta V by delta T, which is equal to minus V by R delta R divided by delta T, which is equal to minus V square by R. So for uniform circular motion, V is equal to minus omega R, where omega is the angular velocity of a particle. So if you substitute V is equal to minus omega R, so minus omega square R square divided by R, cancelling this, what we will get? A is equal to minus omega square R. This is the expression for centripetal acceleration.